Thank you so much for having us. So it's really a joint project. I will present you briefly my outlines. So the idea is to explain the motivation for this work and to discuss the existing previous research on ASR, and the and then I will discuss the two pipelines that we want to compare. We didn't want to make it a kind of competition, but just try to convince the interest of getting big corporate, as Anicia suggested. So I will discuss the results on our test cases. We took, sorry, it's in English. It's a video designed to propose the tests, and then I'll discuss some of our results and present our next plans. So first, motivation. We may be aware of a tool called Youglish that is intended to be a real concordancer that unfortunately doesn't help you to choose the kind of file that are listed, so you don't know what are the videos that are taken by YouTube, and you have no control on the data collection. But we were also inspired by the fact that it seems to us that the technology is ripe. There's an acceptable level of ASR, automatic speech recognition, for the subtitles, and there's the possibility to export this as a different format, such as the SRT format that keeps the timestamps, which is important to pre-process aligners, and the existence of such libraries such as YTPP that is allowed to do scrapping metadata from the YouTube video. So certain amount of research has been dedicated to ASR. Anicia just mentioned the Munich automatic segmentation system, which also has a web-based implementation. The underlying technologies are different, and our study, in a way, allows us to deal with three aligners: the Penn-Forster aligner, which is based on HTK, the Montreal Forster aligner, which is based on MFA, and SPAS, which uses an aligner derived from Julius. And there's been a certain number of inter-aligner comparisons, but to the best of our knowledge, not for the three aligners that are at the core of our systems. So first, the PEASYV pipeline. The PEASYV comes from the name PEASYV, so we try to find easy aligner. This is the graph used in the paper, and you can see the principle out of the YTDLP library. We separate the sound file, the video file, and we separate the texts with the subtitles, and then the idea is to use Pratt to generate the double aligner with SPAS and P2F. In a linear sequence, we first do the scraping, we do the conversion, we do the alignment pre-processing, we do the forced alignment with the two aligners, we add extra prosodic annotation using SPAS, and we end up with a huge final text grid for each video, out of which we can do format extraction and dataset generation. And there's a couple of sanity checks using trapezium plots, and we can do a kind of phonetic analysis with R. So an example of this is the comparison with the standard trapezium for English, and this corresponds to the mean of our speaker. And you can see the effect of hyperarticulation for the reference to trapezium compared to the more connected speech effects of our recordings. There's an HTML rendering where we can look at individual plots, and we can see the different counts and the different means of formants that we have. And we can also do more elaborate plotting with standard deviation. So in a nutshell, we have a certain number of diagnostic files. We have CSV datasets, text grids, and the INSINT labels I mentioned for prosody. We only look at vowel, as the next pipeline I'm going to show, which is for the time being called by Stephen the YouTube phonetic pipeline. The strategy is different. Here, the underlying technology is Jupyter Notebook, and you can see a screenshot here from Stephen's version of a Colab pipeline, so you can try for yourself the technology. It's more customizable because it has this ability of using the Jupyter Notebook. You can choose your acoustic models. For experiments, we've focused on British models. It uses the Montreal Forced Aligner, as I said, a certain number of libraries, such as the Parthenos library, and we can convert the phonemes and visualize them. And in some of his works, Stephen has also used some YouTube metadata to have geolocalization for Australian English corpus that he designed. So as a result, we can compute the number of vowels after the aligner, and we can plot on the typical trapezium square the results. And we have a resulting text grid with the famous waveform, the spectrogram, the token-based alignment, and after the IPA conversion, IPA phone-aligned transcription. The PEASYV has a certain number of extra layers because it also gives the output of the different aligners. So in our initial test sets, we use sentence stress and intonation in English from a YouTube channel which is focused on British realization, with the underlying hypothesis that there was a form of articulation in the speaker, and that we could expect the phone representations on the trapezium to be quite representative of the various vowels, and that is the case. We get similar vowel representations from the point of view of the trapezium. This is the raw data from the YouTube phonetic pipeline, and we have a difference in the number of phones that we counted, and that's the one of the consequences of the use of different aligners. The phone count is not the same when we analyze the data. So we did not go for an overall tentative comparison of the underlying aligners, but just in case you wondered, it looks like the Montreal Forced Aligner has less dispersion than in the other cases. Here is an example based on consonants. Among the points to be discussed are the possible legal possibilities for researchers, and it looks like there's a form of fair use provisions that would enable us to use this kind of publicly available data for research purposes. We also try to see, since we noticed that with PEASYV, with the two aligners, we had a mismatch between the two aligners, can we try to improve quality by making sure we have a match in the aligners? So we took the syllable representation to analyze matches, and based on these results, we have a maybe more reliable version of the analysis, but it comes at a cost of losing a certain number of data points. So for the share of our toy example, we can see that we move from 2018 data points to only almost 2/3 of the results. So there's a lot to lose. We need to do more research in terms of the specific points of analysis. We still believe that there's a great research in the data collection. So we started collecting Nigerian English and Uganda English, but our conclusion, I suspect, is more work is required in this field. So let me just mention two events that shows that this kind of technology is topical and needs for discussions. The first one is a workshop I'm co-organizing on the 28th of March. You can still follow the call for paper. And the second workshop will take place in September, and it's organized by colleagues from Münster. And we expect a lot from these joint discussions. And these are our main references, and I'd be happy to answer your questions if you have any. Thank you.